Hi, I welcome you all to this presentation, and the project that I will be working on is titled Alternative Waste Exploitation, Microplastics in Water and Reuse in Crops. So I will start with some information about me. My name is Harshit. I come from India, and I've previously worked on microplastics for my master's at the University of Delhi. About my academic background, I did my bachelor's in life sciences from the University of Lucknow in India. I then pursued my master's in environmental studies at the University of Delhi in India. And just prior to joining this position under FoodTraNet, I was working at the Indian Statistical Institute in Assam, where we were studying about the atmospheric PM 2.5 trends in Tezpur. So about the supervisory team. At the current position within FoodTraNet, I'll now be working under the supervision of Professor Dr. Maria Dolores Hernando at the Spanish Council of Scientific Research in Madrid. I'll also be working with Professor Dr. Amadeo Rodriguez Fernandez Alba at the University of Almería, Spain, and Professor Dr. Esther Heath at the Josef Stefan International Postgraduate School in Ljubljana, Slovenia. Now, what motivated me to apply for this position at FoodTraNet? Well, I have three major reasons for it. Firstly, I felt that it was a perfect match for my background since I had already worked on microplastics and wanted to research more about it. Secondly, I think this project is going to provide me with a lot of opportunities to work with experts, to collaborate with different research groups and other ESRs, and also grow my professional network. And I also believe that this position and the experience that I acquired during this time is going to be extremely helpful for my future career. Moving on to the background of this project. Microplastics are these tiny particles that are below 5 millimeters in their size. They are often classified as a contaminant of emerging concern and are found almost everywhere. They've been found in our water bodies, including marine, freshwater, groundwater. They've been widely reported inside the bodies of aquatic organisms, reported in certain beverages such as beer, and they are also potentially present in effluent discharges and terrestrial soils. The major entry pathways for microplastics into agricultural soils are the process of mulching, atmospheric deposition, the use of organic fertilizers and repurposed sludge, and also the use of repurposed water from wastewater treatment plants for irrigation. This is in fact the focus area for this particular project. What are the issues with this? Well, firstly, there's a scarcity of both public awareness about this issue as well as sufficient scientific information on it. And because of the lack of sufficient scientific information, the regulatory framework at this point in time is also lacking. The issue is being taken up at policy level, however, we need more scientific evidence to regulate it. The major objectives of our work would be the development and optimization of a methodology for microplastics in soil, to study the interactions between microplastics according to their chemical compositions and pesticide residues in soil, and also to study the bioaccumulation of micro and nanopolymers and contaminants in edible crops. Phase 1 of our project will be dedicated towards the establishment of a methodology and studying the interactions of these micropolymers with pesticide residues. For the methodology, we would be using artificial wastewater with the target contaminants, and the first step of the protocol would be the extraction of these microplastics from the soil. Followed by step 2, which is the protocol for the identification and analysis. Now we plan to use microscopic analysis in combination with micro-FTIR for this step to identify the microplastics and also to analyze their characteristics. We also plan to investigate the interactions between microplastics and the pesticide residues that are present in soil. When in soil, these pesticide residues might interact with the micro and nanoparticles, which would make the polymer a carrier for the pesticides. So to study these interactions, we will be using different polymers and pesticides with different physicochemical properties. Initially, this would be studied in a model to eliminate interferences, and subsequently the interactions would be studied in soil. Also, the pesticide residues will be analyzed using LCMS and GCMS. Then we move on to phase 2, which is the uptake and accumulation. So the hypothesis for this phase, we feel that these microplastics and nanoparticles might enter the plant tissues due to uptake from soil and get accumulated inside the bodies. Now this would be a major concern if we were to eat these crops. But for now, we must remember that this is our hypothesis, and there are very few studies that have started the investigation into the accumulation of nanoplastics in crops. To study this phenomena of uptake and accumulation, we shall be using fluorescent tracer particles, which will then be released into a hydroponic setup, which would be used for growing the crops. And we will be investigating the accumulation of these polymers in different regions of the plant body at different lifetimes, exposed to different micro and nanopolymers with different pesticide residues. At the end of the project, we should be able to come up with a standardized methodology for the extraction, identification, and analysis of micro and nanopolymers, have some information about the interactions of these particles with pesticide residues in agricultural soil, and also have some information on the accumulation of micro and nanopolymers and associated pesticide residues inside plant bodies. That's it from my side. Thank you for your time.